Okay guys, we're going to look at financial maths, and personally I didn't even want to look at it because it's really so simple. Financial maths is not supposed to get you under, and yet most students actually struggle with it, but it's very little that I can say about it. Let's just quickly start with the most important thing: timeline. Okay, I used to, when I taught this at school, I used to, if I didn't see a timeline and you made one error, I give you 0 for the whole question, because without a timeline you're wasting your time and my time, because a timeline is really helpful in order to understand it. So here's the point, is that in a timeline, at any point in that timeline, if I have a value, any value, it doesn't matter what that value is, okay, if I wanted to go forward, okay, all I needed to do was if I wanted to know what's this value in the future, all I needed to do was take that value and add interest. Okay, now whatever the interest was for that period. Okay, let's not call it, let's call it like this, interest. Now how would we get that interest? We would say interest is equal to the x value that we had, okay, times the interest rate for that period. Okay, let's say there's maybe a few periods in here, and over each period he gets, and I'm just going to focus on compound interest, okay, for each period he gets interest, but that would make the calculation a bit more difficult. So let's just say between here and there he got a fixed interest, whatever that interest was, called I. Okay, so this point, this expression would change to x plus ix, and if I take out the x, I would have x 1 plus I. Okay, so there's the standard formula for going forward. Okay, now if I were to go backwards, in other words, let's say, or this value that I have here tells me what is the future value. In other words, the future value is taking my present value, let's call it P, and adding the interest. Now, if I were to go from here to there, I would have to take this value and do the same thing with it. So I already have x 1 plus I. Now I'm going to multiply it with 1 plus I again. So now it's going to be times 1 plus I again. So it is x 1 plus I to the power of 2. So that would be if it went on 2 periods. So obviously if it now goes on a number of periods, doesn't matter how much, that makes now sense why this one will be I plus to the power of n. Does that make sense? Okay, where n just represents how many time periods passed. Okay, now if I wanted to go backwards in time, so just to this point here, I need to know, but okay, this value here is actually now the future value. So whatever this value is here, if this value was y, when it gets here, it's y 1 plus I, like that. So in other words, x, this future value, let me write it like this, the future value was equal to the value in the past. Now I'm trying to get the past value, keep that in mind. The value in the past times 1 plus I. Now I'm trying to get the past value, this value here. So all I need to do is divide both sides with a 1 plus I. So if I divide both sides with a 1 plus I, it becomes y is equal to the future value, and then the 1 plus I, because I'm dividing with it, I can multiply with 1 plus I to the power of negative 1. Does that make sense? Is everyone okay with that? Okay, now the same thing goes. If I were to go back another time period, it would be taking the future value. This is now the future value. If I go back one time period, I have to the power of -1. If I go back more time periods, I'll go back. So for example, p, in other words, it's the value in the past. If I wanted a value in the past, I'll take the future value and I'll take 1 plus I to the power of -n. So do you understand how the present value formula is going backwards in time? That is why the exponent here represents what we call the number of discounts. Each time I go back, I'm discounting it. When I go forward, I'm compounding it. Do you understand? So compound has positive exponents, discounts have negative exponents. So that makes it very helpful to answer some very, very easy questions. So, but the point being that the timeline is very, very helpful. And if there's multiple changes during the year, then it just makes sense to take those changes. Each time a change occurs, just get a new value at that point. Let's look at a few examples. So here's an example that comes from last year's June exam. Okay, so it tells us Susan invests 10. Oh, sorry. Susan invests 10,000 into a savings plan. The interest rate for the first 2 years was 8% compounded monthly. Thereafter, it changed to 11% per annum compounded semi-annually. At the end of the first year, she deposits an additional 500 in the same account, and after a further 10,000 after 5 years. How much money will be in her account after 6 years? Okay, so what is the first thing to do? Timeline. Draw a timeline. I promise you it will be helpful. Okay. So you'll see there's no going back. They ask how much money will be in the account after 6 years. So it's simply starting at this point, saying that initially she added 10,000 Rand into the account. Okay, now let's put in the information as they give it to us. The interest rate for the first 2 years. Okay, so the way I do it is I just cover these 2 time periods with an interest rate of 8%. 8% compounded monthly. Okay, thereafter it changes to 11.5 compounded semi-annually. So I'll do this for as long as it needs to 11.5% compounded semi-annually. Okay, so however many time periods there may be. Then this, remember this is 0, 1, 2, 3, 4, 5, 6. It does seem like 6 will be sufficient. Okay, and then they tell me, okay, thereafter it changed to that. At the end of the first year, she deposits an additional 500. So here's the first year. She deposits a plus 500 at that point, and into the same account, and after another and a further 1,000 after 5 years. Okay, so 1, 2, 3, 4, 5 years. After 5 years, it's another 1,000. And then they ask how much will be in her account after 6 years. So there's the 6th year. And now here's my suggestion. All you do is you start, and at every change you calculate the new value. Okay, that's the simplest way to do this. In other words, let's see how many changes was there in the process. So this would be P0. That means there's no change yet. P0. Okay, where's the first change? 1. So this is going to be P1. So we're going to have to calculate P1. Where's the next change?
2.
At time period 2. So that will be P2. Next change?
5.
then this will be P, well, you can call it P5 because it's at time period 5 if you wanted to, or you can just call it P3 because it's the third time you're calculating a present value, okay? And then finally we want time at 6, so we'll just call that the future value. Okay, so we're going to go calculate P1, P2, P3, and future value there. So imagine that you come to the bank, or Susan comes to the bank after the first day she gets to the bank. What is the amount she finds in the bank account when she gets there? No, it's nothing. She puts in 10,000. So the end of the first day she gets there. Okay, so when she gets there, there's nothing. She puts in and there's 10,000. So P0 is 10,000. Okay. After 1 year, how much is in the bank account when she gets there? Sorry? No?
10,800.
No? How do you know? You don't. You have to calculate it. So in other words, P1, after 1 year when she gets there, the money didn't stay dormant. It was earning interest. When is it earning interest?
First 2 years.
It's getting money, interest, every month because it's compounded monthly. So we must go and work out, okay, what would be the future value? Well, it's the present value times 1 plus I to the power of n. And now, what does n represent? No, number of times. Number of times I get interest in this formula. In the present value formula, it represents the number of installments. But here, I get how many times did I get interest in 1 year? 12 times. So I know that's going to be 12. Each time I got interest, how much did I get? You guys are way too quiet.
You say 8% divided by 1,200.
Good. 8% divided by 12, which is another way of just saying 8 divided by 1,200. Now, why is that? Why do I divide by 12 to answer the question, how much do I get each time I get interest? Because they give me the answer as 8% per annum. That's how much I get per year, compounded monthly. That's why I divide it with 12, because I get 8 in total, but I get it each month, and in total it must be 8. So I divide by 12. That gives me how much I will get every month. Make sense? Okay, so how much do I get every month? 8 divided by 12. How many times do I get it in 1 year? 12 times. Can you give me the answer there, please? 10,829, comma? No, so it just goes on. Okay, now, so store that value in your calculator. If you don't know how, you have to find out. There's usually a little m plus. Store that, or 0.995. It doesn't matter, it's still store it. So there's a memory, ms is memory store. So press ms, and then when you want to use that value, you press mr. That's memory recall. So see if you can find your ms on your calculator. That just stores that value so you can use it later on.
I see M plus.
You guys don't have an ms. Let me see on my calculator. You see, I've got an ms like that. That means you store it in the memory. M plus means you add it to the memory. MR means you recall the memory. MC means you clear the memory. I've got nothing in my memory. if you don't have it, you'll see you have a button called recall and store, RCL. There's a button RCL and a button STO. Usually these two, one is the button, the other one is the shift function. Okay, usually like this. So if you wanted to store it, and you'll see some of your buttons have an A, B, C, etc. Okay, so you can store into any one of those values. So when you press store, so you have your answer, there's your answer, then you press store and you press one of these letters and it will store it in that letter. And then if you want to use it, you'll press shift, recall, and use it, or just the recall button if it's not on the shift function. You get it?
Have to press M plus, just that.
No, if you don't press M plus, because what M plus will do is will add whatever your answer is to what you have in M. So in other words, there's an M button, you'll see there's just an M. Now, if you want to store something in M, you'll press store and the M button. If now at any point you press M plus, it will take whatever answer you have and add it to what you've stored before. No, it's really quick. Well, I promise you, you're going to love once you get how to use your calculator's memory function. You're going to have fun. So it's literally you're just storing it in any value. But I'll say avoid the M if you can, avoid the M pluses and just store it in A and B. So I'll show you. Okay, so remember what we were calculating? We were calculating what she sees in the bank when she gets there. Okay, at this time period. But why did she come to the bank? To deposit the 500. So now, after that, after we have this, we should still add the 500. So at P1, yes, we're getting the value, but there's also a change. So don't go and put your change just now here, plus 500. So you can maybe in your formula just say plus the deposit. Okay. P1, so you can't just now get this answer, and at the end of this answer, now you just add another 500 there at the end. Okay. Make it part of your formula from the beginning. Now, what was the next change? Notice that next change is simply an interest change at this point, which means the interest change hasn't had an effect yet. I don't use the interest change yet. I just need the value at the start of the interest change. So she's not even coming to the bank. Do you understand? But there is a change happening there, so we do need that value. So P2 is equal to what? Okay, it's obviously equal to P1 because now I've already gotten the new value. I'll use my new value, okay, for that time period. So this one doesn't have any additional pluses or anything at the end because there's no deposit or thing that's being subtracted. So what is the value that I'm going to put in for P1? Oh, sorry, I should have done this. This is 11329,99. Was it 9905? Just 995. Okay. So P1 is 11329,995. And then 1 plus, what interest rate am I going to use? Okay, so MK says 11.5. What interest rate has it been getting for this time period? 8. Okay. MK, I thought you were trading in money.
No, I thought you were already calculating the...
Yeah, see, you're already a millionaire. You don't care. Okay. So, do all of you understand why we're using the 8%? The 11%, 11.5 has not been used yet. It's going to be used from on this amount here. That's what we're trying to calculate it. So this one still experienced only the 8%. So it's 8 over 1, 2. And then what does n represent? Number of times I'm going to get interest. How many times will I get interest in this? This was 1 year. How many times am I going to get interest? 12 times. Each time I get 8 divided by 12. So what's our new value? So you press recall. Hopefully you stored it in A. Recall A. Or actually this was the second amount because you stored this in B. And then when I used to do this in my exam, I only figured this out at varsity, but I would put the value that I calculated, I would write on top of it a little A if I stored it in A and a little B if I stored it in B. On my exam, no one knew what my A's and B's were for, I'm sure. But so I would recall value B. Just do my little calculation, 1 plus I over 1 to what, power of 12, and then the answer that I get, I would say store that answer again, STO in, this time I would choose C. And then I'd write a little C, and what's the answer? $379. Guys, in your exam, do not round off. You're only allowed to round off your final answer. So 379. Okay, so what is the rest of this?
You need to write out the whole answer.
The whole answer. 0, 7. That's it. 09. Is that it? Okay, as far as possible. Okay, now the nice thing is you don't have to type this in your next part because you've stored it now, hopefully in C. Okay, so the next change is happening in when? We've already gotten P2. We have the answer for P2 now. P3, that's now at time period 5. Okay, so P3 will take P2 and add the correct interest. And what change happened there? Sorry? Interest didn't change. Interest only changed here. And we've now got the new value, and we'll just apply any future thing. At P3, what change happened there? A deposit. So in your formula, this is what she comes to see at the bank, and then she added a deposit. So now we put in our value. P2 is 12270,379,070,9 times. Now what's going to be the interest and the amount of time she gets interest? Look at your time period. Because it's compounded semi-annually. Well done. So it's 11.5% divided by 200. Okay. And then how many times is she getting interest?
What does it mean?
Semi means twice. Half. June and December, or whenever she started, 6 months later and 6 months later. Makes sense? Does it make? Let's quickly go through those words. It's maybe important to know.
Is it in 3 months or every 4 months?
No, a quarter of 12 is how many? 3. So it's 3 monthly. If I get it every quarterly, it means, so monthly would mean I get it 12 times. Okay. What would bi-monthly be?
I thought bi-monthly was 2, but I don't know. It turns out it's not.
You'll get it 6 times because bi means 2. Bicycle means 2 wheels. But what would semi-monthly be? I don't think they use the word, but what would semi-monthly be?
24 times.
24 times. Because semi means twice. Do you understand? So semi-annually is twice annually. Semi-monthly is twice monthly. Does that make sense? Since they're 12 months, I'll get a total of 24. What would quarterly? Quarterly, how many times in the year will I get it? No. 4 times. Quarter is 4 times. It is every 3 months, yes. So the quarterly and 3 monthly would be the same thing. 3 monthly. So ask yourself, how many times will I get it? What month I get it is not important. It helps me to figure out how many times I get it. If I get it monthly, okay, it doesn't mean I get it once. It means I get it 12 times. Okay, what else could there be? Semi-annually, we said. Semi-annually. How many times do I get it if I get it semi-annually? Twice, 2 times. And then probably the other one is just annually. Annually. Would just be once. They could say every 4 months. Then how many times are you getting it in the year? Then you're getting it 3 times. Okay, good. So because this one was said to be semi-annually, we know we're getting it 2 times. So if I get 11.5 for the year, I get 11.5 divided by 2 per each time I get it. Does that make sense? And now if I do that, how many times will I get interest for this time period?
Once. So starting from P2 or...
We're obviously starting from P2 because that's the last time we...
So it's 6.
1, 2, 3, 4, 5, 6. I get it twice a year and there's 1, 2, 3 years, so I get it 6 times. Do you see? I don't use that formula. A lot of teachers teach formulas, so they will go and say P future value, or I suppose the formula they use is A is equal to P1 plus I divided by M to the power of N times M. And it is big, but this is, well, this is the same thing because I still have that 2 times 3 to give me the 6. But this comes from an understanding rather than trying to remember which formula to use. Okay, what answer do we get? So recall, so you'll press it, recall C, because we stored it in C, times, and then you type out your do you have it?
I'm done, but I used 12,270.397. I didn't add the others.
Then your answer is wrong. From here on, I stop marking. No, I lie. I just you lose a mark there, which was unnecessary. But do I have the correct? Why didn't you use the others?
It's because I'm storing, and when I was storing, I didn't include them. So now I use.
Oh, I see. Okay, but you were using recall. That's fine. Okay, if you used recall from me. Does anyone have an answer for me? We can just see if your answer, how far off is it. Anyone?
So I'm still getting it, like.
Ended at the 07. I didn't include the
You did.
09.
Yeah, that's fine. That's fine.
So it's 17160.90697.
Like that?
And 3.
Okay.
90693.
6937. 3 in a.
Just that.
Just that. No 7 at the end. Oh, okay. Cool. Okay, this is our value at P3. That's what you'll see. Oh, wait, but that's not the end of it, huh? We forgot the plus the 1,000, plus the 1,000, plus the 1,000. We shouldn't forget that. So in the end's 18,160,90693. Okay, this.
Sorry. I said when you deposit, you don't use the depositors. You start adding. You say 1 plus. You say 1,000 multiplied by 1 plus 12, 11 over 11.2 over 200. You don't do that.
So you, in other words, you're not adding your deposit in this amount.
Yes.
That's getting the interest. You're correct. You don't add it, but tell me quickly why not? Why didn't we include the 1,000 in here? Why didn't it also get to be multiplied with this lovely bracket? Yes, it's just getting into the bank account. Okay, he still has to get in on the action. Okay, he's not earned any interest yet. So this is what she finds in the bank account. That's what she deposits, so that this is what she leaves the bank account with. And only now does he start earning interest. In the next 6 months, he'll get his first interest. Okay, and now the final answer was to get the answer at this time period. Oh, sorry. Store STO in, where were we? D. I'm going to store it in D. And now for the final thing here, what's the only thing that I need to do to get my final answer? Paulina, what do you say? I have the value P3. I know the value at this point, how much I have in the bank. I want to know the value at that point. You just calculate, but what happened in this year? What's the only thing that happened throughout that year?
It has interest.
It's only got interest. Well done. Okay, so at P4, I'm only going to take P3 and add the interest that it earned for time period. Okay, so here 18160,90693. 1 plus, what interest are we using? Cool, still no change in that. 11,5 over 200. And how many times did it get interest between P3 and the future value? I should have actually changed this to future value. How many times? Once, twice. So you can't now go back here, because then you've already given all this interest to get to this point. It only got twice. It only got the interest twice. And then we got our final answer, which is something like 20,000 and something. 20,007 or 20,270, something like that. Okay, so we'll press recall D times 1 plus 11 over 200 power of 2. What do we get? This answer I'm allowed to write round because this is my final answer.
20,309.4.
Okay.
573.
So 4, 5, 6. 4, 6. Okay. Great. Okay, let me quickly show you how marks were allocated for this. Okay. The first mark you got in this question was for using the correct interest rate here. The next one for the correct time period. And then for adding the 5. And so just that first part, you already passed the question, since pass is only 30% for us. Okay. So, and then the next question would be to get probably to get this intermediate value, then to use that, and the plus 10,000. Okay, and then again to get this intermediary value. So 1, 2, 3, 4, 5, 6, 7, 8. The next one we've already gave a mark for using the 11,5, so we won't give it again, but we will give a mark for using the 2, and then for the final answer 1. So this, even though it's classified as an L3 question, level 3 question, you can still classify questions into 3 more categories: easy, medium, and hard. And this is a level 3 easy question. So level 3 means it's complex. Complex means there's multiple steps, intermediate process, but the whole thing is actually easy. It's not a difficult question. Okay, do you guys agree?